There you go. Take it you can see that still. Cool. So clean architecture. The idea of this Snackchat is just kind of like an introduction, as I titled it, just to sort of intro people to the ideas behind it, how it works, what it is, and some advantages and disadvantages. It's quite a big topic, so I've tried to fit what I can into 25 minutes. So see how that goes. But yeah. So clean architecture, as the name says, is an architectural approach that you can use for building systems or apps. And the main idea behind it is kind of a separation of concerns. So you separate responsibilities into separate layers and they become independent of one another. Each layer has its own responsibility. We'll look more into each of these layers soon, but essentially a typical structure for clean architecture would be these 4 layers. We have the central layer, which is domain logic, which is kind of like your core business model. So like classes such as maybe a user or a tweet. We'd have business rules on the second layer, which is like operations that your application can carry out, maybe send a message, delete an email. And then on the third layer, which is interface adapters, this is stuff like presentation logic, controllers, gateways. And then on that outermost layer is anything to do with frameworks or drivers. So anything that's framework specific, such as user interfaces, databases, or anything that's networking. And one of the key things about clean architecture is the outer layer. So the dependencies point inwards. So the outer layer depends on its next inner layer, and so on. And the inside layers know nothing about the layers outside them. So layer number 1 in the diagram knows nothing about 2, 3, or 4, and layer 3 knows nothing about layer 4, but it has a dependency on layer 2. And the idea is that we never skip over layers when we're passing data or perform any kind of operations. So layer 4 would never communicate directly with layer 2 or layer 1. It would have to go through layer 3. So if we were performing some form of data request, we'd have to go through each layer to do so. And that sort of helps to tie in with the whole dependency. So we don't want any layers other than the outside ones depending on each other. So that's to enforce that in place. And the whole reason of that is, as I said before, is the separation of concerns. So with each layer having its own responsibility and not depending on multiple places in the system, you have this kind of these bubbles, let's call them, or layers of the onion, which become independent of one another and interchangeable. And the whole point about this, or some of the benefits, is our layers become completely independent of frameworks. So for example, the most outside layer is what contains stuff to do with our framework. So for example, the Android framework. This probably applies maybe to more like web stuff. But for example, say if Android was to disappear, I hope it doesn't because I'd probably be out of a job. But if Android was to disappear in the next year, we could just switch out the outside layer and none of our other code would need to be touched because the only layer that would be affected by that change is the layer with the frameworks in. And the same applies to anything like networking or database. Because none of our layers know anything about what frameworks are being used, they don't really care about anything that changes outside of that. Our code becomes more testable as well because our responsibilities are defined in each layer. We're not trying to test multiple responsibilities in the same test class and have these sort of God test classes with multiple things going on because our layers are so focused, and then the classes within those layers become focused too. The inside layers, so building on the first point of the frameworks, the inside layers become completely independent of UI and any external parties. So we can really focus on building the core business logic and sort of the operations and any sort of data operations before we even touch the UI. In the case of Android, UI can be quite fiddly and can often be quite error prone. So building the core business stuff and all the data responses before we do any of that and ensuring that it's working correctly can help speed up development time because we spend less time trying to fiddle with bugs which are happening in the back end and when we're trying to build the front end. And finally, the bugs become more isolated. So we have these 4 layers, and because the responsibilities are so defined, if there's an error with the presentation, we know exactly where that layer is going to be, and we can fix that and we can find it more easily. And same applies to the UI or anything to do with business operations. By the way, if anyone's got any questions at any point, feel free to stop me or just ask something. So Another point about clean architecture is the modeling. This is probably one of the cons of clean architecture, but we'll come on to that later. Is essentially each layer has its own model representation. So Marcus has seen this before. So if you have like a user object in the most inner layer, and then that user object needs to be carried through each layer will need its own representation of that user object. The reason for that is, again, to remove the dependency on inner layers. So if you only had one user instance for your whole system for each that was used by all the layers, every layer would become dependent on the layer that has that user model. So it kind of defeats, if you were to do that, it kind of defeats the whole point of having clean architecture in the first place. So the idea is that you would have mapper classes which map the models between for each layer, so they become into a compatible type. And what you can do with this is, so say if you get a response back from an API with like a really nested model, this also allows you to sort of map that model down and flatten it into a single instance for use by the next layer. And this practice also helps you to enforce multiple model usage for things like caching and API responses and UI models. So it has its pros and cons. Another point, so that's just an example. So for example, if we were sending data from our frameworks and drivers layer to our interface adapters layer, we'd use a mapper class to map that model A into the representation for model B. So again, our interface adapter layer knows nothing about the frameworks and driver layer. So that's why that model needs to be mapped into the compatible instance. Another key point is layer boundaries. So because of the separation of responsibilities, there's becomes a clear boundary of the interactions that can happen. So we have, one of the key things is we have no direct name references between layers. So from one layer, you'd never call, say if you had like a class called like a cache data store or a remote data store, you would never call it directly by that class name. Those classes would implement interfaces, and you would access those classes via the use of interfaces. And the point of this, if you're familiar with like the repository pattern, it makes your systems more flexible to change. So say at one point, if you're only using like a remote data store, even if you're using an interface at that point, then when you introduce a cache data store in the future, it's just a case of slipping it in there and without having to change much because you're already relying on those interfaces. Like so. So our frameworks and drivers layer would implement an interface which is provided by the interface adapters layer. So to look at each of those layers that we saw before, so the domain logic layer, which is the innermost layer, is kind of the core part of our application. So it essentially just contains our application business objects. So these are like data classes, so like models for a user or models for a tweet. These are unaffected by any operational change, so you only need to change these if something changes on the business side of things. So, for example, the simplified free plan stuff that we added, that is kind of a business change in the user sense. So that is when this layer would change. But if we were adding a new feature to the composer or something, we would never need to touch this layer. So it becomes completely isolated. And the nice thing about this is we can start from the ground up. So we'd start here, if we were building a feature that was a new business change, then we'd start from the ground up and implement the business models that needed to be done before anything else. And in the case of our apps, our domain logic layer would just simply be a collection of classes like so. Literally just classes containing properties for the models that are being used, and pretty much nothing else. So we don't actually have a domain logic layer. We merge the domain logic and business rules layer, but we can come on to that later. The next layer outside of those data classes is known as business rules. So these are rules that are specific to your application, and they're in the form of what are known as use case classes, essentially. And these use case classes are kind of like operations that your application can carry out. So like deleting an email, sending a tweet, sending a message, and they're all just single tasks that your app or system can do. So they are affected by operational change, unlike the inner layer. So if we're changing features, we'd likely need to interact with this layer. And again, another point is they're isolated from any concerns outside of their layer. So in the case of the Publish app on Android, these are some of the use cases that we have. And you can see they're all extremely focused. They're just doing one thing. And again, they have this theme of responsibility, single responsibility in place. And this is generally what a use case class would look like. It would differ between language or platform. But this is a send message use case from reply. Again, it's extremely focused. It's just doing one thing. And we pass in message and an ID. And then we use the repository to send a message. So the interesting part about this is the repository. So that repository is an interface, and that's kind of like a contract with outside layers. So we were talking before about the interfaces, and this use case knows the operations, this layer for the domain logic knows the operations that are to be implemented by the system, but doesn't know the actual implementations. So what this layer does is provides an interface, such as this, for outside layers to implement. So we have this domain logic layer that just defines some tasks that can be carried out and defines the functions that can be implemented by outside layers. But if an outside layer, such as our presentation layer, wants to use this domain layer, so wants to implement it, then it needs to provide implementations for these interfaces, such as so. So we have our business rules. We have a use case class which uses an interface defined in its layer. And then any interface adapter class outside of that would need to implement that interface and provide some form of implementation. So for example, maybe it's like retrieving messages or retrieving updates. And again, this creates a clear line of responsibility because the business rules don't care where the data comes from. It doesn't care if it's from the cache or the remote. It just cares that those methods are implemented. The interface adapters onion ring of application is kind of mainly like presentation and controllers. So any presentation logic of the app for us is this layer is pretty much just presentation logic. If you're using stuff like model view presenter, then you'd probably define like view interfaces as well. So then the UI layer outside of this can use those view interfaces. So the presentation layer, that would, this is similar to the diagram we saw before. So we'd have the use case with its interface, and then the presenter would communicate with the interface implementation of the business rule layer to retrieve some form of data. And the most outer layer is the frameworks and drivers. So the frameworks and drivers can be anything like UI components, network, storage, and it can contain any number of modules essentially. It's just anything to do with anything that's framework specific, stuff that could change quite often or change when you under big implementations. So for example, in our app, we have the interface adapters layer, and then outside of that, we have a data module as well as a user interface module. So user interface and data operations are both within frameworks and drivers, but we separate them because if we were to merge them together, it's kind of too much responsibility going on within a single module. And we can split that out even further. We also have a caching module and a remote module. So our data layer kind of is like the centralized communication part for any data operations, but the caching and remote are split out just because again, the data layer would have a lot of responsibility from the data sources. Again, one of the things about clean architecture is it could be easy to overcomplicate things for what you're building. So this may depend greatly upon what you're working on. Like if you're building a small system that only has one data source and is likely never going to change, then you may not go to this level of abstraction. And again, like I said before, the frameworks and drivers, the user interface is still a part of that layer. But in our case, the data layer doesn't communicate with that at all. They're just within the same onion ring. And within the data layer, so this isn't clean architecture specific. It's just more like coding craft in terms of like patterns. But we heavily use the repository pattern. So clean architecture kind of encourages a lot of like interface usage to have a lot of abstraction in place. So With the interface, so the interface implementation is the implementation of the interface defined within the layer that our use case is in. So that class will communicate with, so our data class at the bottom there will communicate with remote and cache sources. But because we've got those remote and cache sources within different modules, the data layer, again, shouldn't really know or care where the data is coming from. We want some form of abstraction in place, again, to make our system more flexible. And that's where we have what's called a data store factory. So this data store factory uses some variables, such as maybe like a cache expiration, or it might check if there's also stuff in the cache. And then depending on the result of that, it will return us an interface of the data store class. So again, sticking to the outer layer, it communicating within a layer's interface approach. The data layer, the data module, sorry, provides an interface for our remote and cache layer to implement. So our data store factory is going to return us this interface for our bottom class to use to access a data source, but again, not knowing where that data is coming from, which is where we have either the caching layer or the remote layer. And again, the class at the bottom here doesn't know the source of that data because it's interacting via an interface. And that theme is something that's encouraged throughout each layer of our application. Now with clean architecture, there's no rules on the number of layers. Like I know here there's been 4 layers, but sometimes that can be overcomplicating things for what you're building. So you may only have 3 layers. Like I said at the start, the layer in the innermost ring, which defines the data models, and the layer with the use cases, we merge those together into one because it doesn't make sense for us to have a whole separate module just for data models and then have to map between models for no reason at all. So we merge those into one. But then you may have an extremely complex system, and you may want to have 5 layers, you may want to have 6 layers, or even 2 layers. There's no strict rules on how to implement clean architecture. The way we have it is something that looks like this. I tried as hard as I could to fit it into the keynote. But so you can see, like, we have a lot of stuff in Android heavily relies on frameworks. We have like our Android framework for the UI, we have our Android framework for the cache, and we have like other libraries which are frameworks for the network requests. So whilst this doesn't look like an onion diagram, you can pull out parts of the diagram and place them into the onion. So you can still work with clean architecture. This one of the things I found hard at the beginning was trying to make everything look like the onion. And it just was really hard, and I struggled a lot. And then like I found out it doesn't have to look like an onion. It can look like anything as long as there's that separation of concerns in place and the interfaces and dependencies and so on. And this is how we have it in our Android app. And another thing about that is like the frameworks and drivers, like you can split out things into modules if you want to. Like if you don't want to have a direct dependency on an analytics module, that can be abstracted out into its own framework layer. And the same goes for things like pusher or event-driven notifications. This can all be abstracted out into their own modules, still within the frameworks and drivers layer. And one of the advantages of this stuff is simplified and isolated testing. So because we have such focus and simplified classes within each layer, it becomes easier for us to test stuff, and our test classes also become a lot simpler to read, to maintain. So in our case, we have strict responsibilities for what each layer tests as well. And it becomes easy for us to test stuff because things are so isolated. And like I said before, we're not trying to test multiple things in the same class because everything is split up and there's that line of concerns in place. So some of the advantages, it's actually 2 pages of advantages, so these are some of them. So the first one is, easier tests, higher test coverage. Obviously, you still need to be clear of like the testing, the logical paths, but overall, we've got a higher test coverage now than we did before because it becomes easier to test things. It's easier to navigate throughout the project. Personally find so, and I think other people I've spoken to have said similar things, just because you know where things are. Things are so the responsibility of each layer. So if you need to find a class, if you need to find a bug, it's easier to find. It's easier to maintain as well, tying into that. If you need to work on something, again, the classes are smaller. Like if there's a bug in a use case class, they're pretty small classes, or within a presenter. It's easier for us to maintain those classes, because the classes are so focused. It also results in smaller pull requests. So what we tend to do is we try to have pull requests under 600 lines. Otherwise, it gets too hard to check them, and things can slip through that maybe shouldn't have been merged to begin with. So if we work with feature branches, so we can make a pull request for each layer. So if I want to create the domain layer, I'll work on that, and I'll open a pull request, and it'll probably be about 500 lines maybe. And then Victoria can work on maybe the presentation layer, and you can have smaller focus on smaller tasks. You can break up a task into smaller focus tasks, which makes it easy for us to check things before they get merged in, and also reduces like knowledge silos, because tasks are split up so clearly. It can make it easier for us to share tasks, rather than kind of muddle around of, oh, we might have conflicts, we both work on this, or like not a clear line of who's working on what. It also allows us to future-proof implementations. So the interfaces allow us to do this easily. So for example, if we decide in the future to make our app offline compatible, because we're using interfaces, adding databases will be a lot easier for us to do so than it would be if we weren't, because we'd have to sort of implement those interfaces and then change all the dependencies and so on. And there's a clear discipline. So although when I started looking at clean architecture, I found it quite hard to get my head around, and it took a lot of like reading and trying to get things right for Android. But once it's in place, it's quite hard to break it, because there is a dependency on, because there's the rules of dependencies, and you can't access classes directly because there's no dependency there. You have to find ways around that, and those ways around that often tend to be the right way, because that's what you've got to work with. So once it's in place, it's hard to break. So one of the things I like is it allows you to stabilize core logic before you even touch the UI. So you can have a solid inner layers with a bunch of tests, and you can know it's working to the best of your knowledge until a user uses it and it probably break. But the point here is that the UI, you can do all of that before touching the UI, and then you can really focus on creating a polished UI, knowing that everything underneath that is working solidly. There's probably more advantages, and it probably depends on the projects, but those are the ones we've found so far. And for the disadvantages, so it does add a bunch of initial overhead during setup. Like when I started learning it, I think it's like a year ago or so, there was a bunch of learning to do, and some things took a bit longer than they should have, because I was trying to work out, oh, how do you do this in clean architecture? But I think that's the same with a lot of new things. But one of the points of that is it takes time to get used to what goes where as well. So there'll be a lot of like and ahhing, like, oh, should this go here? Should we do this way? And that can make a lot of tasks feel like overkill, and it can be easy to overcomplicate things, because the interfaces and the separation, you kind of want to abstract everything, but again, because if you're making it, that's down to the judgment of what you're working on. So you have to be strict with, like, do we really need to do this? You don't have to follow everything by the book. So you do what feels right for you and the project. And the model mapping can be tedious. This is probably my major pain point, is sometimes the mapping between layers and models, like it is a bit of a pain, and sometimes a model will never change. Like you'll get a model back from the API and you've got to map it all the way into the UI layer, and it kind of feels a bit pointless. We're still trying to find ways to better that. Maybe like making classes, maybe making a library to generate those classes for us. Yeah, I'm still to find a better way to get around that. And again, there's probably more disadvantages, but yet to find them, and I'm sure different projects and different people will come up with different things. Yeah, that's it from my side. I don't know how we did for time. Not bad, 20 minutes. Cool. Does anyone have any questions? I think we've still got like a little bit of time if you've got any questions. I know we didn't go too deep into it, so.
Are there any like frameworks for Android that have this sort of in place? I don't know much about Android, but like, or was this something that you felt like you had to do pretty much from the ground up?
Yeah, there's no frameworks that help you implement this. There's some libraries and frameworks that help you do like model view presenter and model view intent and model view model. There's ones that help you do all of that, but clean architecture, like no one's done that yet. I think that's why we made the boilerplates, because like there's a lot of people who want to work with clean architecture, but I think it's a bit hard to get started. So I think that might be something we might explore in the future, because we're using it in publish and reply. So maybe in future we could do something like that. But I think for now, the boilerplates are as close as we've got.
Oh, that's awesome. Thank you.
Sorry. Any more questions at all, or are we all good?
I don't know if it's a question. One thing that would have been, I think might be valuable, or I think would be a little easier for me. I agree that the model mapping is probably something where people will break down and violate the principles, because you don't really have anything to change between layers. It'd be like, why should I bother? I'll just take the shortcut, and then the whole thing eventually will fall apart. It might be interesting to see an example of what someone has actually implemented at 2 different layers. Just to help reinforce to people, yeah, it's a bit of work, but it's not that much work. Or here's an example where you've created both models, but there's not really a difference between them. And here's one where you actually did need to augment the underlying one.
Okay. Can you see the screen?
Yeah.
Cool. So this is reply. So if I'm trying to think what might be the best. So for example, this is a place where I feel it might be necessary. So within the data layer, we have this folder entity class, which doesn't have too much to it. It's just like a few like strings and a Boolean. So we get this back from a remote layer, but we have to save it to the cache. So where's its representation? So this is the cache folder model, and this is why this is a case where I feel it's necessary, because this model, because it's cache specific, it has a lot of like stuff to do with database, again, framework stuff. So it wouldn't feel right to be passing this to the UI, because it's a completely different responsibility. Like the UI shouldn't care about like database names or like primary keys. So that's one reason why we map between that. So again, this is just like one of these classes. These mapper classes are pretty small, and they just like take one input and return another. And again, in this case, like these are pretty much the same. There's a value here, which is an organization ID. So for caching, we have to save that. But this is one of the points where I feel that is necessary. Again, because of the references in this cache folder class. And going on from that, we also have in here we have this is what we get back from the API. So again, so we have the cache and remote layer, say at the top, and then they both map into what was in the data layer, the folder entity. And the reason why we have a separate class for the API response is, again, because of the framework references. If we were to share one model between these 3 layers, we'd have frameworks from the networking, we'd have frameworks from the cache library, and it just gets like we have to have these annotations for the naming that comes back from the web. So personally, I think in Android, I'm not sure about other platforms, I think that's quite a common behavior to have different models that you cache and different models that you can have from the API. Then an example of where that feels kind of where the mapping feels a bit pointless is probably here. So we're going from the data layer to the domain layer, and we map from we map from this entity class to this folder class, and the properties are exactly the same. And this is what we're trying to work out at the moment. Like, it's not too much like overhead to create that, but at the moment we're trying to think of ways how we can improve that, because from the data layer all the way to our UI, well, all the way to the presentation, the models don't change. Once they hit the UI, they change, because the UI contains like view classes and framework specific stuff. But anything else in between is just like pure Kotlin or Java. So we're trying to find a way at the moment to better that. I don't know if does that help?
Yeah, cool. Thank you.
Cool. Okay. Was there any other questions, or all good? Cool. Good stuff. Okay. I think that wraps it up. Thanks for